And I'm telling it again, because I couldn't record that one. Your cooperation is very much necessary because this time is yours, and we have to do all these things in well, and we have to understand the content well. Then, because of that, our primary objective of this class is that you, on your side, that facing your examination well. Okay. Then, if you come to the classes regularly, then it's not like other subjects, that this subject is a very practical subject. I am not saying that others are not practical, but anyhow, that this, if you understand this content then and there, and at the same time, that when I explain all these things, it may be easy to you without wasting your time, and you can use those time for other course modules also. Okay. Then when you understand this one well, then little time you need to do all these things. Okay. Then the subject is, that is the nature of this subject. And before I start all these things, and I am B.H. Sudanta from University of Moratuwa. I'm attached to the Department of Information Technology. I am the Dean of the faculty at the moment, and maybe the couple of years, I don't remember, that maybe 4 to 5 years, and I am coming to an institute to do this course module and other circuit theory course module. And there we had some kind of experiences that I could see all the students and there, then, but here we don't have that chance. But anyhow, that maybe in near future, sometimes that we may meet. Anyhow, that as I mentioned, that this is your time, and I am recording this lecture, and after that I will put those things to your the common resources in place. Then you can refer this one and again. Uh, then if you have any kind of problem, then you can contact me. You can ask all these questions at the very beginning of the next lecture. Okay. Okay. Then actually that the kind of an advantage of this online lectures is that you can refer it again and again, because that we have video and you can refer that one. And with that, I am most of the thing I am typing on a Word document, and you can see that one on the video also. Then if it is necessary, I can provide that Word document also for your references. That's how we are going to conduct this lecture series, and you can see my screen. And the topic of our subject is this a part of your module. I think you is a basic electronic for chemist. With that module, that we have two sections. One is digital electronics section. The other one is analog electronics section. And under this digital electronics sections, we are going to discuss uh, the basic concept which we need to design a digital circuit. And after that, we are going to discuss some kind of that little bit advanced topics in addition to those things. Okay. But before we start this lecture, before we start these theoretical contents, okay, now you know that the subject, the topic is digital electronics. Okay, then what is your experience regarding this digital electronics? Some of you might have some experiences, maybe at your school time, maybe you have done certain other extra activities using electronics, and some kind of circuits you have developed, maybe in your school time, maybe in different places that you have different experiences with that. Maybe some kind of, sometimes you are under your O-level science subjects also, part of these things you may be touched. Or sometimes that personally you have some kind of interest and you have done certain things also. But that is one part of the story, that when you consider this audience, you may come from different disciplines, different backgrounds. And some of you might have certain experiences and some of you might have certain idea about this one, but some of you might not have even a small idea regarding this one. But it doesn't matter. All of you can go with this lecture because I am starting from the grassroots level. Okay. So starting from very basic level, we are going up to the topic we want to talk. Then because of that, it doesn't matter. No one should have that any kind of that different feelings. Because of that, we are going to talk about this electronics and other things. And I sometimes I am okay with that one. I'm not okay with that one. But both parties can enjoy this one. You can hear this word. You can enjoy this subject because this is a very easy subject. You have my word. At the end, you may realize that this is a very easy subject compared to the other things. Okay. Why? The digital is something like that. Its nature is simple. That is its nature. Okay. Then forget about this digital electronics word. What about the digital word? Have you heard that word before? Maybe in your lifetime, it may be. Many times you have heard this word. Have you used? Sometimes maybe yes. Have you seen that one? Maybe yes. Because that, I'm not wasting the time that until you provide some answers. But anyway, that if it is necessary, you can write something on chat that we can see it. Then, or you can at any time you can interrupt me. You can ask any type of question. Because it doesn't matter that others are not asking questions. That if you have any kind of problem, if I any kind of question, you can ask me at any time. You can raise your question. It doesn't matter because all of us are here to learn something, to grab something at the end. Okay. Then what about this word digital? Where can we find this one? In many places, I think you have seen this word. What is that? For what people are using this one? Where you have seen this one? In which places you have heard about this one? Where? Okay, with those old experiences, that what do you think about this word? That when you hear this word, what do you feel? Is it some kind of that happy feeling, or it's some kind of that maybe the sad feeling? You're okay to write something on chat. Yes. Thank you. That one of your colleagues that has given an answer that it's happy. Okay. But why is that? I think you can see that a different maybe the devices are coming time to time. Maybe the digital phones, digital monitors, digital computers, the digital control washing machines, and recently I think maybe the couple of years time that you have seen the fridge refrigerators. They are coming that sometimes the numbers on the front door, the controllers are digital, and you have your remote controller that you can change all these things. Maybe the couple of decades back we had a when you use radios and TVs, those very big CRT TVs were there in our living room. But now most of the time that we have this LCD, LED kind of TVs, and their controllers are digital. And not only that, when you see a conditioner, your washing machine controller, and all these things are there. That maybe previously we had knobs to tune a channel in a radio, but now you have some kind of buttons to change the increase or decrease volume and to change the channels also. But those things are there. Then little by little, all these versions are becoming very popular and people are using those things. People love these things. Why? What do you feel? Because of what we are using those things. Yes. Yeah. And sometimes that you have one of the answer, maybe the convenience. Then we can say that easy to use and say those are features, or maybe you can say its benefits, easy to use. Then and what about the features? And more features are there. No? Then rich features may be there. And what about the size of those devices? Then can you notice this one? Those things are maybe most of the time small in size. Then I think you might not have some kind of experience that earlier we had with a couple of decades back. We had a very big mobile phones. Those are analog mobile phones. It's like a brick, very big one. But today we have very small mobile phones. Those are digital versions, and not about your smartphones. The smartphone again, they are becoming very much large. But the small mobile phones are there, the digital versions, and we can take the advantages, the benefits of those things. Then what else? What about the power consumption? Low power consumption. The goal is that they are having very much low power to give the operations. Okay. Then what about the prices? If I write this one, do you agree with me? The cost is very low compared to the previous ones. Okay. Because of these reasons, we can list many things now. Okay. Then like these things, then because of these features, because of these benefits, sometimes the people might love these things. To have some kind of idea from you, okay, that I have taken this example for your weekend classes also. Now this is your weekday class. Then I have taken the same example to you also. Otherwise, that is not fair. But assuming that you are watching movies, I think most of you might watch movies, but some of you are watching movies using your mobile phone. Then it's good that not to watch movies like that, because most of the things in the movies that you are missing those things. That too. That when you, I'm not going to talk about that how to make movies, but anyhow that the people who are making these movies, that they are spending much more time and much more money to include many things to the movie, and some of the scenes and some of the colors and some of the facial expressions, we will miss those things if we use the very small tiny screen to watch movies. But anyhow, that assuming that you are a movie lover and you have a very good maybe display, very big display to watch movie, but you don't have a sound system, then you are using your TV set sounds to have this movie sounds. But one day you will realize that the having a good sound system, it may be a great effect. It will add those things. but without having good sounds that you cannot enjoy it much more. That with that idea, and one of the assumption is there that assuming that you have enough money, you are going to buy a sound system. Okay. Okay. Now one day you are going to buy a sound system and you are visiting an electronic store. When you go there, you can see one side there are a lot of sound systems, but they are analog. The other side of the racks that you can see that different type of sound systems available, they are digital. Okay, assuming that both type of sound systems are providing same quality and you have enough money, which one you are going to buy? Which one? Yes, digital. Okay. Okay, one of your friends that written there is digital. Assuming that all others are going with that idea, can I continue? Okay. Why you are going to buy digital? Because of these reasons I have mentioned and some of the reasons that you have already written in your chat. And there may be certain reasons to buy a digital sound system. And you have some kind of belief there, some kind of understanding there. These digital sound systems might give a good, very good quality. But sometimes that analog systems might give the more than that. But anyhow, that's the general idea we are having. Why? Because at the moment that this digital word is other than a technological word, we can see this as a marketing word. Most of the time, if it is possible to wrap something with a digital wrapping paper, definitely we will buy that. That type of idea is established in the market, in the society. If it is digital, it may be good. That idea is there. And to have that idea, to establish that idea, to support that one, those digital systems are providing the features and the benefits and all these things. Some of these things are we have written there. Because of that, you might have that idea. Definitely, you might buy a digital sound system. Then it may be easy to use and user friendliness. It may be there because of certain reasons. It may be your choice. Okay. With that, I think it's not supporting to my this question, but can I ask a different question from you? Have you seen that most of the time the digital version of the different devices are coming into the market, and we are suddenly grabbing all these things. They suddenly check for example, your TV, and we have taken that one. Sorry for that disturbance because in the daytime that we are receiving some kind of call. But anyhow, that we were in the discussion. There is a trend. I think you have noticed that most of the time that different devices are coming into the market, digital versions, and we are replacing our old things and old analog devices. We are replacing when the digital version is available. For example, your radio, your TV, and mobile phones, and old washing machines. And day by day, we are replacing all these things, our old devices, when the digital version is available. It shows that there is a trend in the market, there is a trend in the world all the time when the digital thing is there. And yes, some of you have raise your hand, maybe accidentally. But anyhow, that if it is necessary that you can raise your hand, then you can ask any question. And if it is there, that if it is not possible, then you can write on the chat also. Okay. Anyhow, that maybe coming back to the question, then that is there is a trend. Okay. What do you think that one day can we eliminate all the old systems and maybe old analog systems, and one day can we convert everything into digital? What do you think? What do you think? Can we convert one day everything into digital and throw all the analog systems and old systems away? Yeah. Without wasting your time, and if I give my answer, it's not possible. It's no. Simply, it's no. Not possible. Why? Because I'm taking the answer from the different angle. Because the whole world is analog. We are analog. Our whole day-to-day activities are analog. Because of that, we cannot convert everything into digital. Okay. For example, when you want to give a telephone calls to the other friend, then you can use your mobile phone, but you are talking, then that action is analog. Your words are analog, your sound is analog. Then we have to convert it to digital, and we can send that digital signal to the other end. That the other end, your friend's mobile phone, that digital signal will be converted into analog. Again, that analog signal is coming out. That one can your friend can understand only that analog signal. He cannot understand digital signals. But we are using all these things. We are using all the digital devices to give some kind of easiness to our life, get some kind of relaxation to our life. Then, because of that, we love those devices. But we have to realize that we cannot convert everything, and how these digital devices are working and how these things are giving these benefits and all these things we have to understand. And knowing all the things regarding digital, we cannot have that idea that everything can be converted into digital. Basically, it's not possible. But we have to go there to the digital world and use those things for the benefits because of the benefits they are providing, and come back to the real world. And that connection, the interfacing between this analog world and the real world to the digital world, it may be there. Then go to the digital world. Then after that, come back to the analog world. Then that connection, that interface should be there. So basically, I'm giving that example that when you look at the outside, you can see that the birds are flying, the trees are waving, and wind is blowing. All these things are analog events. What about your father's, mother's love? Is it digital? Sometimes your one may be digital, but that is not. Yeah. But with that understanding, you can come back to the digital, and with that, we are going to learn regarding this about these digital principles and all these things, and you can become maybe the couple of hours time, you can become a digital circuit designer. That proud may be there, but with that understanding, we can do it. Okay. Then my next question. Okay, how these digital systems are giving all those features? What is the secret behind this? How these digital systems are providing this one? It's very small, the power consumption is very low, it's easy to design, it's low cost. How? Now we are coming to our topic. Now we are coming to our lecture. Excuse me. Hello. Oh, no, no, no. Oh, oh. Hello. Then, why these systems are providing, how these systems are providing? Because of they are working on digital states. They're working on two different states. Then that is the shall we say it's a logic states, because they are working on logic states. Actually, there are two logic states there. Two logic states. For example, we can say on and off, or you can say high and low. Maybe you can say true, false. So actually, we need two different things, two different extremes to represent these two logic states. But actually, these logic states are different. But we need something to represent those things. And when you have a switch, you can have that two state is there. Switch may be on, switch may be off. Then that is a digital device. We can consider this as a digital device because it's having two states. All the things we have to convert into this two state logic. Then maybe they can say it's white and black is also it doesn't matter. It's possible. Okay. Then this is the secret behind all these things. It's having two logic states. But when you think about that, the origin of this digital electronics, it's going back to Second World War. Because during the Second World War, that maybe the U.S. Navy, as far as remember, that U.S. Navy people that they wanted to have some kind of secret signal system, a secret system, when they send their maybe the messages and other things that other parties should not be able to catch that one and understand. Then they wanted to have some kind of decoded system. Then they had a 10-state logic devices. Then at that time they didn't think about that two-state logic. That they thought about a 10-state logic because of that we are using decimal number systems to represent those things. That they had 10-state logic. Then with the decimal number system 0 to 9 we have 10 digits. Then they had 10 different voltage levels to represent those numbers. But actually the maintaining of this 10-state logic is a really difficult. But if you know about that, how to maintain these two voltages, how it is difficult, then you will definitely realize that the maintaining of 10 logic state is not possible. Because of that, the today world that we are not using 10-state logic, but still that US Navy people, they are using their systems. But all other world digital systems are based on two-state logic. Then because of that, we are going to talk about only this two-state logic. Okay. Because of this simplicity, the digital systems can provide those features and the benefits and everything because of this simplicity. It's based on two-state logic, maybe on and off, high, low like that. But when it comes to the real circuits, that we'll explain that one later. But in the circuits that the circuits might not understand on and off, high, low, true, false like that. But they are working on voltages and currents, and we are representing those two-state voltages with these two words. But otherwise, that all the time we cannot say it's a 5 volts, 0 volts, 3.3 volts, 0 volts like that, 0 volts, 12 volts like that. We can't say like that. Because of that, we have the representative words for those two-state logic voltages. That is on and off, true, false, high, low like that. Okay, that is the thing behind this one. Okay. Then now we have logic states, but to make real actual circuits, that this explanation is not enough, that we to design a circuit that from this moment we are collecting some kind of tools aiming designing of simple digital circuits. Now logic states, we can understand that, but logic state is not enough. We need something else. That is a number system. We need the kind of number system we need to be used with this two-state logic. I think what are the number systems we are using our day-to-day life? Decimal number system. Decimal number system. With the decimal number system, what is the base? Base is 10. Okay. What are the digits? Decimal digits. That is 0 to 9, 10 digits are there. And some other number system, maybe octal number system. What is base? Base is 8. Then what are the octal digits? 0 to 7. 7, 8 digits are there. But what about the binary number system? What is the base? Base is 2. Then binary digits, that is 0 and 1. And you can see that it's exactly matching with our two-state logic binary number system, because that we have only 2 binary digits. Okay. Then this is 2 digits. But then we have to select a number system for this one. Then we can select this binary number system to be used with our two-state logic. Then hereafter, we don't say those are binary digits and we are using 0 and 1. Then we can use this 0 and 1. They are binary digits. Then, but actually, hereafter we don't say it's binary digits. We say it's bits. Okay. Then 0 is a bit and 1 is a bit. Okay. Like that. Then you can use that 0 and bit. Then we can use this 0 and 1 for the representation of our two-state logic. Then we can use 1 can be represented using 0 and off can be represented using logic 1. Then hereafter we say that these binary the digital systems are working with 0 and 1. But you have to remember that when you say this one, be careful that because the digital circuits cannot understand zeros and ones. They can understand only 2 voltage levels, high and low, 2 different voltages. But to represent those voltages, we say we use this 0 and 1. Then you can, with that understanding, you can say digital systems are working on two-state logic, that is 0 and 1. It's based on 0 and 1 like that, you can say. But remember that circuits cannot understand zeros and ones or any number or any character. But they are working on voltages. Okay, now it's okay. Then after that, to have some kind of system that we need to have variables to make a design. Then variables we need and some kind of that mathematical operations we need. And then those kind of things are things we have to use with this one. Then what are the mathematical operations we can use with our two-state logic? So what are the mathematical operations we are using in our day-to-day life? In our day-to-day life, addition, subtraction, division, multiplication, we are using those things in our day-to-day life. Then can we use those things with digital systems? But we have to take some kind of different kind of operations with this two-state logic. Then when you think about this one, then the Boolean algebra is there. The entire Boolean algebra is based on true-false logic. It's again two-state logic. Then we can take something, some operations and some kind of that the Boolean operators from the Boolean algebra. We can learn them. But we are not going to talk about the entire Boolean algebra. It might take maybe a couple of years. But we are taking some kind of concept from Boolean algebra. The first one is Boolean variables. What's a variable? The time to time it's having a different values. It's not a fixed value is there. Then we need a variable. For example, if you want to make a small temperature monitoring unit, the temperature value may be the variable. Time to time, the temperature value may be varied. Then we need a variable to make those systems. But here we are using Boolean variables. For example, if A is a Boolean variable, then what are the values A can take? One time it may be 0, one time it may be 1, nothing else. Then it doesn't matter that you don't think about much more regarding these variables, that how we are going to handle these variables. That is a very, maybe a very difficult thing. No, it's not like that. B may be also Boolean variable, then B also can have 0 and 1. That's only. Those are the Boolean variables and very simple. Okay. Then, for example, hereafter maybe A may be 0. Then when A is 0, we can say that is A bar. Okay. When A is 1, we can say that is A. Okay. What's the difference between this one? That we have to differentiate this one. Then this is A bar. And when A is 0, we can say it's A bar. When A is 1, then we can say that is A. Hereafter, we don't say that A is 1, A is 0 like that. When you look at that, that A bar is there, you can assume value is 0. Then you look at A, you can say it's for the B also same thing. If it's a B is also Boolean variable, B bar is 0, B is 1. Like that, you can use those things. Okay. But if you have any question that you can ask that one. These things, I think, nothing difficult. You may understand those things. But then we have to take some Boolean operators. But when I write these Boolean operators, I think most of you know these operators. This is a not operator. This is a O, N, no, and exclusive O. These are the 6 basic operators we are going to take from Boolean algebra. And based on those things, but when you say the not O and no, those basic 6 operations, then you can apply those things to the Boolean variables. But on a paper, you can write everything that you can apply AND operation to the A and B variables. Then you can take the result like that. Those operators you can apply. But you have to think about, but this is not a paperwork. This is not something that we are solving problems on a paper or on a book or something like that. We have to do with real. The real circuit should do that one. Then definitely you will realize that to make a not operation, if it is not a paperwork, then we need a circuit which is doing this not operation. The circuit is having ability to do the not operation. Then that circuit is a not operator. Then different circuit is having a different ability to do the operation. then that circuit is a O operator. Okay. Then based on that, we can say these logical devices. Logical devices are there. When I write the different name for this one, definitely you know what it is. I can say these are logic gates. The logic gates are providing those things. Then we have developed certain circuits to give these operations. Then not to give the not operation, we have not gate. To give the O operation, we have O gate. Like that, those are circuits. Those circuits are providing those functions. Okay. Then quickly we can go these gates one by one. The not gate is providing not operation. When you consider this gate, that we have a circuit symbol and truth table and notation. The circuit symbol for NOT gate is something like this. It should have a single input and single output. This is the input A and this is the output, like that. Okay. NOT gate, definitely it has only single input and single output, nothing else. And truth table, that this Boolean variable, this A. Actually, the what truth table is, the truth table explains all the function of the circuit. Okay. Here, this A is a Boolean variable. Then what are the values A can take? Because A is a Boolean variable. It's a Boolean variable. Then A may be 0 one time, A may be 1 another time. Then this is F output. Then when you give 0 to this NOT gate, its output will be 1. When you give 1 to this NOT gate, its output will be 0. It always negates it. It always inverts the value it's receiving. That is output. The notation is A bar. You can say F equals A bar. When you give this A here, output is A bar. Now this is A bar. Okay. But if you have any kind of problem, that a question that you can ask me. It's not gate. Second one, it's O gate. Then symbol of this O gate is something like this. Minimum we need 2 inputs for O gate. Maximum there is no theoretical limit, but minimum we need 2 inputs. One is A, the other one is B. Then in the truth table we have 2 input columns. Previously we had only single input. Now we have 2 inputs. Then when A is 0, B may be 0. When A is 0, B may be 1. When A is 1, B is 0. When A is 1, B may be 1. Those are the all possible combinations. Then F, the O, that operates something like this. When any of these inputs are there, any of these inputs are 1, output will be 1. But here, no one is there. Because of that, output will be 0. The notation is this. A plus B. This is not addition. This is O. A, O, B. Okay. This is A, O, B. 0. Third one, AND gate. AND gate, the circuit symbol is something like this. AND gate also minimum we need 2 inputs. It's having 2 inputs. Maximum theoretically there is no limit. Okay. Here also 2 inputs are there. Then we need 2 input columns. 0, 0, 0, 1, 1, 0, and 1, 1. Those combinations are there. And gives 1 only when both inputs are 1, 1. For all other combination, it gives 0. The notation is A dot B, or you can simply say it's AB. Both are okay. Okay. The next one. If you have any kind of question, please let me know. Fourth one. It's no gate. Actually, no gate is not a new gate, but it's a combination of O gate and AND gate. But here we have a separate no gate. And the O gate truth table is, you may remember, the 0, 1, 1, 1, 1 is opposite of this one, 1, 0, 0, 0. The notation is AOB. You can put inversion here. It's no. Actually, it's something like this. We have O gate, and after that we have NOT gate. Something similar to this one. Then up to this point, it's O. This point, this is AOB, and this point we have VBA. Okay. Then this is no, and this one. So, NAND gate, you know, AND gate. And here, this is NAND gate. Truth table is opposite of N. It gives 1, 1, 1, 0 here. The notation A dot B bar O. AB. Like previous one, this one also can be considered as two combination of two gates. This is something like this, and after that you can take the output of AND gate through a NOT gate. Then here result is AND, and here result is NAND. Okay, the last one. Exclusive. And output is here when the both inputs are having same values, output will be 0. When the input values are different, it will give one output. Here also both inputs are same, then output will be 0. Okay. The notation A exclusive OB. This is the notation. Okay, those are the 6 basic gates we need to design a circuit, and we are using those 6 basic logic gates to design whatever the circuit we need. It doesn't matter. It may be a computer. It may be a very small the temperature controller. Whatever the circuit, that circuit is digital product. Then we are using these basic gates to make those circuits. It doesn't matter that circuit is how much complicated. Okay. Any question regarding these sections before we move into a new part? Okay. If it is not, now you can design your own digital circuits. Okay. Using the knowledge that so far we have gathered, using the tool set we have collected, we can try to design digital circuits. Okay. Are you confident enough to do the design? Okay, before that, what do you think that? how can we remember these gates and what are the function of these things? What is this? So all the time, if it is necessary to invert your input value, if you want to bring that the whatever the value to the other state, so that if it is 1, the other one will be 0. Okay. Then if it is 0, then other one will be 1. Likewise, that all the time we have to, if we need a kind of requirement, we are having to convert whatever the value to the other state, other value. So definitely you have to use a NOT gate. Okay. Then what is the actual meaning of this one? That is it. And what about this O gate? At any time, because that when you have a problem, then you have to divide your problem into small pieces that each and every piece will be addressed by one of these gates, one or couple of these gates. Then you have to bring all the problems into small pieces. Okay. Then if you need to check that when you have two inputs or maybe the more than two inputs, and if you want to check that one of these inputs are true, one of these inputs are having one, then what do you need? What do you use? You can use OR gate. And here, if you want to check that all the inputs are there, all the inputs are true, all the inputs are having ones, then what's the gate you can use? So gate. Sorry, AND gate. Likewise, no and NAND gates are the opposite of those things. An exclusive voice having a different flavor. It gives all the time. Both inputs are not equal. It will give output as one. Okay, I'll give a small example to you. Assuming that you are a designer. Okay, one of your customers are coming to you and explain he's having a problem. Maybe this is the problem. He's having something like this. This is his room. With this room, he's having two entrances. This is entrance A and this is entrance B. Okay. According to him, his requirement is he wants you to make a circuit when one of these doors are open. You have to turn on an alarm because he wanted to know that one of these doors are open. He wanted to know it. Then we are connecting these doors and we put some kind of sensor here. That sensor produces a signal whether it can show that whether the door is open or closed, and it produces the signal. Here also we can place a sensor, and that sensor, digital sensor, is also providing signal information. Then the one may be open, and the sensor value is 0, door is closed, like that. Okay. Then you want to make a circuit, something like this. Okay. Then you can connect these two inputs here. These inputs are coming from the sensors. This is input A and this is input B, and we are connecting an alarm here. Okay. So some kind of circuit should be there inside this box. That circuit should check that all the time whether the conditions of the doors. Whether one of these doors is open, then it has to sound this alarm. If both doors are open, it doesn't matter, but it has a sound. But what is your choice? What type of gate you can use to solve this problem? What is your choice? Which gate we can use to solve this problem? Which one? And this is the one of the maybe the problem with this online lectures, that we don't know that whether you are there or not, you are sleeping or not, and actually that you are alive or not, we can't see. We can't. Okay. Then what is the solution? Yes, O gate. Okay. We can have O gate for this one. We can easily, you can put an O gate here. It gives the solution. Okay. Now you can have some kind of understanding regarding this one. Okay. Assume that a different time. Okay, you have developed this circuit as given to your customer. Now its requirement is okay. No, in a different time, maybe after a couple of months' time, he's coming to you. No, no, no. This is a real headache. This one, and I don't want this circuit. And can you make this circuit that when the both doors are open only, the alarm will be sounded? If he gives that type of request, then what will be our solution? Or this time he wanted to have a circuit when both doors are open only. At that time, we have to sound an alarm. Then what is solution? Yes. Now we can change this O gate to AND gate. Then now here we can take an AND gate and we can take input from B and A coming from both those. Then we can put an alarm. Then that is a solution. This is what is the condition. One of the doors. Here, both doors. Are you okay with that? Okay, if you are okay with that, then that means that we are ready to design a circuit. Okay. Before that, can we do a small exercise? For example, if I give a circuit like this, for example, we have input A and input B, and I can take this one and put it this. And what is this output? It's AOB. Okay. Then I am putting this one into a different gate. And here we have another input, that is C. I can put this C to a NOT gate. Then what is here? It's C bar. And I am taking both of these signals here. And this is at this point, this is one input is AOB, and here we have C bar. Then the function of this AND gate is taking AND operation in between this A plus B and C bar. Then what is the output here? This one and C bar. Okay. Likewise, that can you try to write output values of the following circuits? This is A, this is B, this is C. Okay. Can you try to find these outputs? You can see this one. No? I'll give some time to understand this one. This is A, B, C. Three inputs are there. This gate receives A and B. Then this is AOB. And here this NOT gate receives C. Then output is C bar. And this AND gate gives the AND function in between this input and this input. That is A plus B dot C bar. Okay. Here also one. This is one gate, and you can try to write those things. Third one here, A, B, C. This one. This is second one. And this is third one. And this is the fourth one. Okay, shall we try one by one? And here we have A bar, and this gate is receiving A bar and B. Then its output is A bar B. Then A bar B is coming here, and C is coming from the other side. Then this is A bar B O C. Okay, is it okay? Okay. Here we have A bar, and this is B and C. Then this gate output is A bar B C. This one C bar is coming, B bar is coming, and A is coming. Then this is A B bar C bar. And this gate is taking exclusive operation from both inputs. One input is A bar B C, the other one A B bar C bar. It's taking exclusive operation between these two inputs. Okay, that is number 3. Number 4, here this gate output is A and B, and this is A, the other one is D bar, because this gate output is D bar, and here you have C bar. Then this NO gate is receiving AB, AD bar, and C bar as its inputs. It's taking AB, AD bar is a O gate, and C bar. These are the 3 inputs, and after that is a NO gate. Because of that, on top of that we have bar. Is it okay? Now, any one of you have a problem, now we can discuss. I think this one. And most of you have written those things on your chat. Check whether that you have all these things in correct form. And how can you draw your circuits? I think some of the drawing conventions are there, and so that we can use 2 methods. Maybe some kind of old convention is there that when we have something like this, and something like this. This is jump over wire, and here with that connection, this is connected. We can consider this is a connected one. This is not connected. But here is not connected. This is connected. But we don't have a dot in between these 2 wires. That is one way of doing it. But other way is that you have crossing 2 wires here, but we have to put a dot here. Then it shows connected. But if you have this way, there is no dot here, it's not connected. Because of that, you have to use one of these things, maybe methods to draw circuits. This is method 1, old one, and this is method 2. But do not use both methods because that is confusing all the. This is here is connected, is not connected, but in this method is connected. Because of that, you have to use method 1 or method 2, either one, not both. But I have used the second method. All the time when there is a connection, I am putting dot there. Okay, now what is this? When you have a circuit, now you can write an output equation for this one. Then what is the other way, reverse of this one? When you have an equation, okay, for example, when you have an equation, you should be able to draw a circuit for this one. If you have this one, then how can we draw a circuit for this? Shall we try? Okay, shall we try this one? There's only 3 inputs, A, B, and C. First we have to make A bar. Then we'll take an operation between A bar and B. Here we have A B bar, sorry. This A bar B. Then we can make O gate to combine these two. From F, A bar B, and C. ඕක ඒගොල්ලෝ ගෙනියයි. මම ඒගොල්ලන්ට කියන්නම් ගෙනියන්න කියලා. මම ගෙනියන්න ඕනේ. චෙක් කරන්නද? ඔව් එතන තියෙනවා. දාලා මේ අර මැෂින් එක ඒගොල්ලෝ දෙන්න එවන්නම් මේ. හා. අර දෙක ගෙලෙවද? ගෙලුවා? ඒක වාහනේ දාගෙන නෑ ඔය පල්ලෙහාට ගෙන. ගෙනාවද? ඔව්. යා වාහනේ මම කතා කරගත්තේ ඒකද? මම ඉඳන් කපලා අරගෙන ආවා. Okay, this one we have A, B, C, and D also. Then first we have to make A bar. Then another AND gate we need to make BC. And then we have to make C bar D. Here we have C bar D. This one BC. And this is A bar. And we can combine these three using 3 input O gate. This is G. A bar, BC, C bar D. This is A, B, C, Can take an AND gate, and this is AB bar. This is C bar. And we have to make this BC bar also. B C bar also. First we can take exclusive OR gate, and we can combine, can take AND gate and make this B bar C and A. And this is ABC bar, and we have to take exclusive OR gate in between these two. And here you have C bar exclusive O, this one. And after that you need another OR gate. Then you can take this input here. SSH. And this one, we have to make B bar and D bar. We can take 3 input NOR gate. One input is A, the other one is B bar, and this is C. Then from this gate you can receive A plus B bar C. This is no. And you have to make AB. This is AB. Another one, C, D bar. And we can combine these two using one NOR gate. And we can combine these two using another AND gate. And this is K. And now at the end, what you are supposed to know, you should be able to draw circuits when the equation is available. When the equation is available, circuit. Okay, then you can convert equation into circuit. Into circuit. The other way around, when the circuit is available, you should be equal to when the equation is available, it is necessary to draw the circuit. Equation to circuit conversion. When the circuit is available, write the equation. Okay, basically circuit to equation conversion. If you are okay with this one, now we are ready to design circuits. Okay. Any questions? Anything? And this exclusive operation for 3 more inputs and exclusive OR gates are not possible for more than 2 inputs. One of the question asked from your colleagues. Okay, if you don't have any question, then we can finish the class now. And you can go through all these things, and I'll put this video to your whatever the place that resources are available, then you can refer it. And if you have any kind of question, you can at the next day, at the very beginning, you can ask those questions. And yes, next day we can start designing of the circuit. Okay, have a nice day. Thank you.